The Ulam spiral, or the prime spiral, is an important step in understanding prime numbers, and it has mathematicians stumped. But what is it exactly? Picture this. You're in the middle of an incredibly long, boring, dull class. So you scribble mindlessly in the corner of your paper. You might shade an impossible triangle, or maybe draw a super S. We've all been there. Seriously. Even mathematician Stanisław Ulam, who, in the middle of what I can only assume was a mind-numbing meeting in 1963, arranged positive integers starting at 1 and then going around themselves in a square spiral. He amassed a couple hundred numbers, then went through and circled every prime number in the spiral. What at first glance appears to be random dots with no order, definitive, albeit broken diagonal lines, can easily be spotted. While one might make the argument that it is simply the human mind making patterns out of randomness, that is not the case. In fact, if you take a square spiral of positive integers and circle the random numbers, no patterns present themselves. Here are two spirals. The Ulam spiral is on the left, and a spiral of randomly selected integers is on the right. The diagonal patterns are glaringly obvious in the prime spiral, but nothing can be identified from the one on the right. These diagonals occur even when the center of the spiral is not equal to 1. The most famous variation being the Ulam spiral that begins at 41. This version has one of the longest unbroken strings of primes on a diagonal line. So what does this all mean for the math world? Well, everyone can identify prime numbers from a given set of integers, but as of today, there is no known way to find the next prime in a sequence. Prime numbers appear random, and there's no telling how much distance is between one prime and the next. Some might follow in close succession, while others might be spread widely apart. For instance, if you look at a sequence of primes, it is mathematically impossible to determine the next prime without looking at each number in between and individually identifying whether it is a composite number or a prime number. An Ulam spiral might help to determine future prime numbers by the diagonals. Some diagonals have more prime numbers than others, and these diagonals have a quadratic polynomial modeled by 4n squared plus bn plus c. Therefore, it can be inferred that some quadratic polynomials have more primes than others. As of today, that has not been proven and remains a conjecture. And there's still no explanation behind those diagonals. But it does bring up an interesting theory that maybe prime numbers aren't as random as you think.